Okay, so today, this is like the end of what you have had before, so it should be mostly review. Right, we know what a system is, we know what a solution to the system is, we know how to solve by graphing, substitution, and today it'll be elimination. And then after that, we'll move on to, okay, well, what if they're not linear? What if there's actually some squared terms in there? What do you think happens when there's squared terms in there? You might have a quadratic equation to solve at the end, something like that. And we're going to learn how you can do it in the calculator, right? Get very proficient at that. So here are the steps to solve a system by elimination. And so I include a 0 step just to say that before you start, the equations need to be in standard form. We're talking linear here. So in standard form with the x terms lined up, the y terms lined up, the constant terms lined up on the other side of the equal sign. That's usually the way it's presented. Right? If that's true, then you go on to the next step, or the first step. But even the first step is sometimes not necessary, because the whole goal of elimination is that you're going to get to a step, which I've got as a second step, where you add or subtract the equations to eliminate a variable, right? But if that's not going to happen, based on what you're looking at, then you might have to multiply one or the other equations to make it so that when you add the equations or subtract the equations, you cancel a variable. So if necessary, you're going to multiply. Once you're ready, you add or subtract the equations to eliminate one variable, and then solve for the other variable that's left. You eliminated one, there's one left, solve for it. Right? And then when you get that answer, you need to substitute that answer back into one of the original equations. Solve for the second variable. So solve by elimination. Equations are in standard form, no problems there. The x terms are lined up, and the y terms are lined up, and the constant terms are lined up. If I were to add or subtract these equations right now, would it eliminate a variable? Is 3x plus 6x or 3x minus 6x going to cancel anything? No. What could I multiply by one of these equations? So you could multiply the first one by 2. Okay, what would that look like after I multiplied by 2? Okay, 6x minus 14y equals 20, right? And then what are you going to do to cancel a variable? You would subtract, right? Now my bet is that when you did this before, you might have been taught like that you always try to get opposite coefficients so that you would actually add to cancel. Is that true? Did you add or subtract, or was it mostly always adding? I've taught out of books that only teach that you make them opposite so that you can add, but it really doesn't need to be that way. So if you wanted at this step here, you can multiply the first one by 2 and then you would subtract the equations, or you can multiply by -2 and then you would add. It doesn't matter, it's choice, right? I'll just do by 2, right? So if I multiply the first one times 2, then here's a new system, 6x minus 14y equals 20. And we still have the second equation, 6x minus 8y equals 8. Okay, that is called an equivalent system. It'll have the same solutions. Okay, so now, because the 6x's are the same, if I subtract the first line minus the second line, it'll cancel the 6x's. Well, that means I've got to subtract negative 14y minus negative 8y and 20 minus 8, right? Whatever I do here, I got to do here and here. So subtract. and I get 0, 0 equals negative 6y, 0 minus 6y equals 12. Do you see that? Okay, that's the end of the second step. So the last, where? Well, it's negative 14 minus negative 8, which is like negative 14 plus 8, which is negative 6. Okay. So now I have to substitute this y into one of the original equations, and it doesn't matter. You could take your pick. I'm just going to, almost as a matter of routine, just take the one that's on the bottom, so I can more easily write it like right after each other. So I'm going to take this y equals negative 2. I'll say 6x minus 8 times negative 2 equals 8. 6x plus 16 equals 8. 6x equals negative 8. X equals negative 8 over 6, which is negative 4/3. And again, how would I check it? Plug it in, see if it works. Right? I think the first, if I do the first, or let's do the second equation this time. 6 times negative 4/3 would be negative 8. Then minus 8 times negative 2 would be plus 16. Negative 8 plus 16 is 8. It checks. Is that right? Okay. So try that one. Okay. So which equation would you multiply by? Probably the first one by 3, although somebody actually multiplied the top by 5 and the bottom by 3 to make the x's cancel. That's fine, but it's a little less work, right? To just multiply the first one by 3, because that'll make the y terms opposites, right? So that's 9x plus 9y equals negative 45, right? Don't forget to multiply a term by that number. Okay, the second equation, I don't need to change. So what am I going to do to those equations to eliminate a variable? Add or subtract? Right? These are opposites, right? So we're going to add. Right? So this is going to be a plus. 14x plus 0 equals negative 42. 14x equals negative 42. X equals negative 3. And then you can come up here, right, put it in there. 5 times negative 3 minus 9y equals 3. Negative 15 minus 9y equals 3. Negative 9y equals 18. Y is negative 2. So negative 3, comma, negative 2. Okay, see what's next. Okay, try that one. Okay, will you be able to just multiply one equation to create the opposite or equal coefficients? Probably not, although I've seen students, they'll do this, right? They'll go multiply this one by 4.5, because that'll give you a negative 9y. Okay, that'll work. then you got to do 4.5 there and 4.5 there and add them up. But most likely, you're either going to be multiplying this one by 5 and that by 8, or maybe this one by 2 and this one by 9, something like that, right? So take your pick. There's no wrong answer there, or wrong way to start. How many cancel the x's? How many cancel the y's? I think more cancel x's than cancel y's, because the y's are already more cancel the y's because they're already opposites. But I'm going to do the x's. So multiply this one by 5 and this one by 8. And our equivalent system then is 40x plus 45y equals 75. And 40x minus 16y equals 136, I guess. Subtract, right? So that cancels the x's. And 45 minus negative 16, 61y. 75 minus 136 looks like negative 61. So 61y equals negative 61. So y is negative 1, and then I'll take this and plug it in here. So the solution is the point 3, negative 1. Okay. So one last, you try. So did you have to multiply anything? Not really, right? Because the x's are both 5 x's, you might as well just subtract. So first step, subtract. So we get 0 plus 2y equals 0.8. Divide by 2, 0.4. Okay, then you got to plug that in somewhere. I'll go up here. 5x plus 5 times 0.4 equals 5. 5x plus 2 equals 5. 5x equals 3. 3/5, which is 0.6. Okay, that's it. That's homework.